For the last 6 months, we have spent many late nights at SFU's Trottier Observatory measuring light from the classic Cepheid variable star known as RT Auriga, and many weekends eagerly learning about the math and physics behind this star. When astronomers such as Henrietta Leavitt and Edmund Hubble used variable stars in their calculations, our understanding of the sheer size of the universe changed forever. This project, although it did not require us building anything, was extremely research-heavy and allowed us to learn about various scientific concepts such as spectroscopy, radial velocity, and logarithms. The goal of the project was to measure the magnitude, or brightness, radial velocity, and the distance to the variable star RT Auriga using the Trottier Observatory at SFU. We would then use the data we collected to write a scientific paper for the Journal of the Royal Astronomical Society of Canada. A Cepheid variable star, or specifically an intrinsic one, is a star that expands and contracts at a regular interval. This is likely due to the ionization of helium atoms inside of the star. As helium heats up, it becomes doubly ionized. In this form, it is more opaque and will heat up more quickly. As the temperature of the star goes up, it will expand. As it expands, it cools down, and the ionized helium atoms regain their electrons, becoming more transparent. Once cooled down, the star will collapse inward and heat up again, continuing this periodic cycle. We have been able to analyze this by using spectroscopy, which is the science of analyzing light. We have been able to analyze this light by using a spectrometer, which is a device that splits up light into various wavelengths in order for you to actually measure them and to discover information from them. Sir Isaac Newton discovered that visible sunlight could be dispersed into a continuous series of colors. As research into spectroscopy progressed, scientists began analyzing stellar spectra and realized that the scattered light could reveal much information about its parent star. The reason why lines appear on continuous spectrums on a spectrograph is due to either the absorption or emission of photons. As electrons of certain atoms absorb a photon, and due to mass energy equivalence, or equals mc squared, they jump to a higher energy state, and they cause interruptions in their continuous spectrums known as absorption lines. Alternatively, as electrons drop to lower energies, they release photons. Again, due to E equals mc squared, these photons create signature lines on darkened spectrums, allowing the observer to recognize the chemical composition, or maybe even a Doppler shift. Our project schedule was admittedly a little bit sporadic and not very planned because our project is so dependent on the weather. You can't actually observe spectra if there are clouds in the way. Because of this, we've had to wait for clear nights, which don't come very often in Vancouver, and whenever those do come around, we try to go up to SFU Observatory and measure the light there. Or we spend weekends with Howard Trottier as he gave us personal lessons on the physics and the math behind variable stars, measuring their distances, measuring their radial velocities, etc. Dexter's and I's roles were quite similar because we didn't actually have to build anything, so we didn't have to allocate our time into creating individual components of the project. Instead, we both worked on research, we both understood how spectroscopy worked and how to analyze the data using the software provided. We managed to collect enough data to create graphs such as these. The first graph shows RT Auriga's radial velocity, or how quickly it's moving away or from us, in kilometers per second, and over its phase. So at what stage of its expansion or contraction it's at. The second graph shows RT Auriga's apparent magnitude, or how bright it appears to us, over its phase again. The only reason why we weren't able to submit our findings to the RASC journal in time for the end of the capstone project was because we weren't able to collect enough data, and that was not our fault, that was because of the weather. So this is a project that we'd like to continue, and we'd like to submit an article for it in the RASC journal. Unfortunately, Auriga is starting to set right now, so we won't be able to collect any more data this summer, but throughout university, we will be able to have opportunities to come up with Howard, and he has invited us to come work with him as well.